All right, tomorrow's test is 15 questions. You guys are allowed to use a calculator. I'm going to pass your quizzes back here in a minute. You can ask questions as soon as we're done with that. But it's going to be on expanding and condensing, pulling apart and smushing together. And then a little bit of direct and indirect or inverse variation. And then simplifying, multiplying, and dividing rationals. So when you look at, I'm going to do all the highlighted ones. The rest of them are, they're very similar, but I posted all the answers so you guys can see everything worked out. But if you look at number 23, all right, 23, is this already smushed together or is it already pulled apart? It's already smushed together. Okay, now guys, look, in between each either number or letter, I know you don't see anything, but what's happening between the 10, the x, and the y? Multiplication. What does multiplication become? Addition. And what do exponents become? They become coefficients, okay? So I have log. How many times do I write log? I write log as many times as I need to. Every single thing gets its own. So I have log 10 plus what? Log, good, of x cubed. And then I have what? Plus log what? Y. Perfect. Are we completely expanded? What's one thing I need to do? I need to take this 3 and bring it where? Out in front. Guys, what number is right here that we don't see? 10. You can simplify this a little bit more. What is log 10 of 10? What's going to happen with log little 10 and a big 10? It's going to cancel out and become a what? A 1. Good. So plus, I have my 3 log x plus log y. All right, there's no multiple choice on your test tomorrow, so everything's going to be free response, which I think is a good thing. Because if you forget to maybe bring that 3 down out in front, that's only a couple points off. But if you just guess the wrong multiple choice answer, then the whole thing would be wrong. So I think free responses are good. Anybody have any questions on that one? All right, let's look through 25. Is this already expanded and we're smushed it together, or is it smushed together and we're pulling it apart? Where it's already expanded. So I'm going to look at a couple things. Do we both have, say, in the log? Yes. So I'm going to rewrite that log little 7 one time out in front. So now let's think about this. What does this 3 become? The exponent. Good. And what does this plus sign become? Multiplication. So give yourself a little roadmap of what to do. This becomes 4 to the 3rd power times what number? 6. Perfect. Now, some of you would stop there, but you can keep going. Can I simplify this more? Yes, this is log 7. What is 4 to the 3rd power? 64 times 6. Can we multiply that a little more? Yes, log 7 of what? 384. It doesn't say to solve this. All you're doing is condensing it. But if you were going to solve, if you were going to do that in your calculator, how would you enter that into your calculator? Perfect. Log 384 over log 7. Good job, guys. The visually bigger number over the visually smaller number. Very good. All right, let's look at 27. I got a whole bunch of ln's. Yeah? So how many times am I going to write ln? One time out in front. Now let's talk about this. What does this 2 become? An exponent. What does this 5 become? An exponent. Okay. What does this plus sign become? Multiplication. And what does that minus sign become? Perfect. So take it step by step. You don't have to do it all in one step, but this is going to be x squared times 2 to the 5th power. Agreed? Divided by what? 8. All right. Now we can simplify this a little more. I'm going to rewrite my ln, and I'm going to leave my x squared hanging out here. What is 2 to the 5th power? 32 divided by 8. Some of you got here and you're like, can I do anything else? Can you divide 32 divided by 8? What is 32 divided by 8? So this is ln of 4x squared. Now again, each simplification that you do, condensing, I guess, you would earn points for. So show as much work as you can, guys. Show what your brain is doing so that I can give you credit for it. Everybody good? All right, let's go to 29. Change of base formula. I cannot make this one any easier, guys. How do I put this in my calculator? log 9 over log 7. You need to show me that. Don't just get whatever you get in your calculator. Show me what you did in your calculator. You might hit a button incorrectly and get the wrong answer, but if you show me that you knew how to do it, it's only a point or two off. What does this equal? About how much? Say it again. 1.130, something like that. Okay. Anybody have any questions on that? Okay, super basic, super basic. All right, let's go down here. They're giving you 2 log equivalents, and then they're asking you to solve. You have to think how you could make this number with the 2 numbers they gave you. All right, I have log 5 of 3, and I have log 5 of 6. What could I do with 6 and 3 to make it a 2? Division. I would have to say, in your mind, you'd think, okay, I'm going to work backwards here. I have to say log 5 of 6 divided by 2. What does 6 divided by 3 equal? 2, correct. So when we have division, guys, when you pull it apart, when you go to evaluate, what does your division become? So this would be the same as log 5 of 6 minus log 5 of 3, correct? And then you use the equivalence that they gave you. 1.113 minus 0.683. You guys agree? And what do we get when we subtract that in our calculator? 0.43. Perfect. So when you are given 2 log equivalents, you have to say, okay, how can I, given those 2 numbers, how can I make the number that's in the problem? If you look at number 3, I did number 3 2 different ways, because you can look at this 2 different ways. I have 9. All right, I have 9. Given my information here, how can I make 9? I can square 3, correct? What's another way I can do it?
Can you add 3 and 6?
That's a good question. Can you add 3 and 6? Does it work out if you add 3 and 6? Let's try it. Let's do squaring first. All right, I'm going to say log 5 of 3 squared. Agreed? You guys agree? Okay, so when I expand this, what does my 2 become? A coefficient. So it's 2 times, what is the log 5 of 3? 0.683? Yes? Okay, and then when I multiply those 2 together, what do I get? 1.366. All right, another way you could look at it, you could say it's log 5 of 3 times 3, correct? Agreed? So when I expand this, when I pull it apart, it's log 5 of 3. What does my multiplication become? Addition, log 5 of 3. And then we would add these 2 together, so 0.683 plus 0.683. What do you get? 1.366. All right, now another question. You guys just asked me, can you add 3 and 6? Okay, so think about this. Let's try that. You would say log 5 of 3 plus 6, correct? Now, when you expand that, do we expand using addition? No. We condense using, right? Our addition becomes what? Multiplication. But when you expand, so you can't go from that. You have to think in terms of, when you're smushed together, you have to think in terms of multiplication and division. So then when you pull apart, you can use addition and subtraction. Good thinking though. Good thinking though. But when you're already smushed together and you pull apart, you have to think in terms of multiplication and division. All right, you guys okay? All right, let's go to the next one. God bless. All right, we're going to solve. What is the beauty of solving? You get x equals. What can you do with that? You can plug it in. You guys have a calculator. You can plug it in. So what we have to do is look at something like 31. What kind of a problem am I starting off with? Exponential or logarithmic? Exponential. What's the opposite of exponential? Log. Look at your calculators. What's on the exponential button? Log. What's on the log button? Exponential. So you know at some point you're going to have to take the log. There's nothing to do here. You can't divide by anything. You can't add or subtract. You just have to take the log. So when I take the log of this side, what is the little tiny number that I'm going to use? Why is it 5? Because there's a big 5. Good. And what you do to one side of the equation, guys, you do where? So I have log 5 of 8. What happens over here on the left with log 5 of 5? Cancels. So x equals, how do I put that in my calculator? Perfect. Log 8 over log 5. And what does that equal about? 1.292. And what can I do with that number? Throw it in your calculator. Hit 5 and raise it to the 1.292. See what you get. Hit 5 and then raise it. Use the caret button or whatever. 1.292. What do you guys get? 7.99999. Is that real close to 8? You got 8. Okay, so yours is a little higher. That's fine. That's fine. But you get real close, right? When it says check for extraneous solutions, what do they mean by that? Check for solutions that don't what? They don't work. Can you take the log or the natural log of a negative number? No. All right, I want you to look at 33. There was a couple people had questions on something like 33, which is good. Okay, I'm starting with natural log. Look at your calculator. What's the opposite of ln on your calculator? E, okay? So you know at some point you're going to have to do an E. But I have 2 ln's on one side. Can I smush those together? Yes, I could rewrite this as the natural log of what? X times x plus 2, because my addition becomes multiplication, correct? So equals 3. So at this point, guys, the only thing left to do is to get rid of that ln. So what did you just tell me the opposite of ln is? E. So you'd put a big E, and you would put everything else upstairs. And what you do to one side, you do where? So you put a big E, and then 3. So what happens with E and ln on the left-hand side? They cancel. So are you guys okay with me saying this is x squared plus 2x equals, guys, put e to the third power in your calculator. .08. All right, so do you guys agree with me this is a quadratic? So this would be like x squared plus 2x minus 20.08 equals 0. Have we done any factoring that involved decimals? No. You guys aren't going to have anything like that. But I do like the fact that you understand how to get to that point, because what is the opposite of ln? It's e. We condensed. Right? The process is fine. At this point, you would have to use your graphing calculator, which we're not going to do. So you're not going to have anything that comes out like that. But I want you to understand how to get to that point. You may have a quadratic, but one that'll factor. Like that doesn't factor like you know how to. But yeah, you might have a quadratic. Just say, guys, you came out here and you had like x equals 2 and x equals -4. What do you have to do with those two numbers? You got to check. Just say those were two valid answers. If I plugged 2 in here and 2 in here, would that work? Are we okay? Yeah. What about if I plugged a -4 in? Why not? Because it would make so you would just cross it off or something like that. So you might, yes, you'll have quadratics that you have to check to make sure that the logs don't become negative. These are not the answers to that question, just a thought. All right, let's look at number 1 here. Why is this one so easy? They both have the same base, right? So what can we do? You just cross them off. That's it. And then you just say x minus 7 equals 2x plus 3. If the bases are the same, or you can get them to be the same, just cross them off. So when we solve, subtract 2x from both sides, and add 7. You guys okay with that? Okay, so negative x equals 10. So what's x equal? Negative what? Perfect. What can you do with that? Plug it in. See if you get the left-hand side equals the right-hand side. Every single time you guys get an x equals, you should check it. Let's go over to 5. 5 is just like the first one we did. What kind of a problem is this? Exponential or logarithmic? Exponential. So what's the opposite of exponential? Log. I'm going to take the log of this side. Log base what? Little 8. Why am I using a little 8? Because there's a big 8. Perfect. What you do to one side, guys, you do where? Perfect. What happens to log little 8, big 8? Cancels. So I get x equals, how do I put that in my calculator? Log 35 over, perfect. Which is what? 1.710? Yeah, did you got it? Yeah, okay. And then throw it back in your calculators, just see if it works. All right, there was a question on the quiz that a lot of you got confused on. It was something just like this. A lot of you tried to change the 3 to a 9. What should we do here? What would be a common base between 3 and 9? Correct. You're going to change, guys. You need to change this. 3 to the x plus 1 equals, what's another way I can write 9? 3 squared. So 3 squared, and then that exponent is still there, x minus 3. Change to the base that you can, like I can't multiply 9 by itself and get a 3. What would I have to do to 9? I'd have to take the square root, so you'd have to go to the 1/2. Don't do that. Always go to the smaller base. Now that the bases are the same, what can we do? You can cross them off. So over here you have x plus 1. Over here, you have 2x minus 6. You guys agree? All right, so move letters to one side, numbers to the other. Negative x equals negative 7. So what's x equal? X equals 7. And again, the beauty behind x equals is that you can plug it in and check your answer. Really, really important that you guys do that. All right, how we feel? We okay? All right, let's do 15. What do you guys notice about 15? The logs are the same. They're both on one side, though, so what should I try to do? Smush them together. I'm going to rewrite log base 3. And what do I do with 3x and 2x plus 1? I'm going to multiply them, because when we smush back together, when we condense, addition becomes multiplication. So this is 3x times 2x plus 1. Now on your quiz, a lot of you guys got to here, and you made one little mistake. The only thing I have left to do is get rid of that log. So how could I get rid of it? I write a big 3. Perfect. And then everything goes in the exponent. This is where you guys made a mistake. Some of you left it like that and crossed this off and said equals 2. Is that true? What you do to one side, guys, you have to do where? To the other. So you write a big 3. Do you see how they're the same? And then this goes in the exponent. So what you end up with here is 6x squared plus 3x equals what number? Equals 9. Good. Now is this a quadratic? Yep. We're going to bring the 9 over. So 6x squared plus 3x minus 9 equals 0. We got to factor it. What should I take out of all three of these? All three of them have a 3, so take that out. 6 divided by 3, this gives me 2x plus x minus what? 3 equals 0. Now we're going to factor a times c. Leave that 3 out here. You can let it hang out for a minute. But what are the factors of negative 6 that multiply to give me a negative 6 but add to give me a 1? 2 times negative 3. What's going to give me a negative 6 when I multiply, but a positive 1 when I add? Negative 2 and plus 3. Now, guys, I do this a little differently than you may have been taught, which is fine. I have to do what with this 2? What do I do with that 2 out in front? If you multiply this right now, x times x is x squared. That's not what I want it to be. I want it to be 2x squared. So what do I have to do with that 2? Since a is not 1, I have to take that 2 and divide it underneath here. If you guys were taught to factor when a is not 1 a different way, do it however you want to do it. That's how I do it, though. So this I end up with 3 here, 2 divided by 2, so I have x minus 1. This does not divide pretty, so this becomes my coefficient, 2x plus 3 equals what? 0. Now what do you do with each piece? You set everything equal to 0. Does 3 ever equal 0? Nope. So here I have x equals what number? 1. Here I have x equals what number? If I move the 3 over, it becomes negative 3, and then divide by 2. So I get what? Negative 3 over 2. All right. Are both of those answers valid? How do I check? Go back up to the original. If I plug in a positive 1, do either of those logs become negative? No. So we're good. 1 is fine. What happens when I plug in a negative 3 over 2? It becomes negative. So is this a valid answer? No. So x equals 1. Now the only algebra 2 part of that was understanding this part right here to make this an exponential with a base of 3. Everything else, guys, was algebra 1 factoring. We've got to be able to factor. It's super duper important. You guys with me? All right, let's go to inverse and direct variation. How do we show whether it's direct or indirect? First thing we want to do in this case is solve for what number, for what letter? We want to solve for y. So when I solve for y here, I have x, y equals 5. What do I do to both sides to get y by itself? Divide by x. So y equals 5 over x. Inverse variation is y equals a over x. Are we in inverse variation? Yes, so right here you guys will tell me inverse. In order for you to get credit for this question, just by writing inverse or direct, you're not getting any points. You have to show me why. You have to show me the work behind it. If you just guess right, no, I'm not giving you credit for that. Let's look at number 3. What do we solve for? You always solve for y, so multiply both sides by y. So 15y equals x. Now what? Divide by 15. So you have y equals x over 15. Well, direct variation is y equals a times x. That's direct. Inverse is y equals a over x. What is this one? This is neither or neither, however you want to say it. Good. Got to be in the correct form. All right, how do we figure out, guys, given a table, if something is inverse or direct?
Let's divide it.
Okay, you have to multiply and divide. When we multiply, look, x, y is our what? Inverse. Very good. Y divided by x is our what? Direct. It's the opposite of when you have it in the equation because you're looking at it in a different way. So if I multiply 7 times 35, I get 245. You guys will have a calculator. If I multiply 11 times 55, I get 605. Is that a constant? Is that the same thing every time? No, so you can just stop there. Say it again. Because it has to be a constant. You have to get the same number every time. So since that didn't happen, you can just stop and say, oh, it's not inverse. So let's figure out if it's the opposite one, the direct. If I take my y and divide it, what's 35 divided by 7? 5. What's 55 divided by 11? 5. What's 75 divided by 15? 5. What's 100 divided by 20? 5. Is that a constant? Are you getting the same thing every time? Yes, then that's why this is direct. But again, just guessing, inverse or direct, you're not going to get credit. I have to see why you guys are telling me yes or no. If you look at this one, if you multiply every time, you get the same number. Every time you multiply, you get 32, so that would be inverse. All right, when you look at these, it says x and y vary inversely. They're telling you to use this formula, y equals a over x. They're telling you that it varies inversely. So now you plug in, you've got to figure out a first. We have to solve for a. So you're going to say, okay, well, y is 5 equals a over what? A over 1, okay. So what does a equal? A equals 5, okay. Did we solve the problem? No, all we did was find the equation. Your equation is y equals 5 over x. Now, what do they want us to do? Evaluate when x is what? -3. So y equals 5 over -3. What do you get? You can just leave it like that. I think on the review I have it backwards. I think I put -3 over 5. So just fix that. You can put it as a fraction, decimal, it doesn't matter. This one's a little harder because it has a fraction in it. Varies inversely, so y equals a over x. Let's find the a first. Your y value is that positive 18? All right, so your y value is 18. We don't know what a is, and we have divided by 5 over 2, correct? No, so this can get a little confusing, I understand that. Rewrite this, guys. This is 18 equals, how do you write a divided by 5 over 2? If you keep, change, flip, do you guys agree that you get that? All right, you might want to do that first. You might want to do that first. Now, a couple ways you can do this. You can say, I'm going to come up here. 18 equals 2a over 5. See how I multiplied the a in the 2/5? Now, how do I get a by itself? Multiply both sides by 5. Good. So what's 15 times, 18 times 5? 90 equals 2a. So you divide both sides by 2. And a equals what? 45. Okay. Now that we found out what a equals, let's evaluate where x equals -3. So y equals 45 over x. When I evaluate where x is -3, I have 45 over -3. So what would y equal? -15. I'm going to come back to the word problem because I want to make sure I get all the simplifying ones done. I'll do it on the video, though, at the end. All right? All right, let's go through these. Simplify. How do you simplify? There's a million ways you could do this. What did I do? I just said, okay, I'm going to multiply the numerator. So I have 80. How many x's do I have? X to the 5th, y, over 5x squared y to the 3rd. You guys agree? Yes or no? All right, so let's simplify here. What's 80 divided by 5? 16. If I have 5 x's on the top and 2 on the bottom, we subtract. What's 5 minus 2? 3. So I have x cubed, and I have 1 y on the top and 3 on the bottom. So how many am I left with? 2. Where are they? On the bottom. If you have, wherever the exponent is higher, that's where the letter stays. I have 1 y on the top and 3 on the bottom. So look, when you cross them out, where are they left over? They're on the bottom. If it says to simplify, guys, you just want to factor. And it says if possible. You may not be able to simplify everything. So let's look at number 1. Can you factor anything out of the top one? No. Just stays as 4x cubed. In the denominator, can we factor anything out? An x, okay. So bring that out. Becomes 3x squared plus 7. Remember, they are connected with that plus sign. So what can now cancel? Top and bottom, what can cancel? This x down here, and one of them up here, right? So this becomes what? X squared. So this simplified is just 4x squared over 3x squared plus 7. That's it. That is simplified. Let's look at number 3. Factor the numerator and the denominator. What can you do in the numerator? What can we take out? Take out an x, and I'm left with 2x minus 5. Look at the bottom. What are the factors of 12? That multiply to give me 12, but add to give me 7. Multiply to give me 12, add to give me 7. x plus 3, and x plus 4. Is there anything on the top and the bottom that is exactly the same? No, so that's it. That is simplified, guys. All you did was just factor the numerator and the denominator, but there's nothing that they have in common, so there's nothing to cancel out. That is an okay answer. Don't second guess yourself and say, what did I do wrong? I can't figure it out. There's nothing wrong. That was fine. All right, let's go through these. Kind of want to do them at the bottom. Well, I have room in here. All right, you want to factor the numerator and the denominator. It's already done for you. Do you see how this x plus 3 is already factored? Put it in parentheses. Anything on the top and bottom, guys, that is exactly the same you can cross out. So tell me what we can cross out. X plus 3? Okay. Anything else? I have 4x's up here, and I have 5 down here, so it leaves me with how many? Just 1. So what is my simplified answer? X minus 4 times x minus 2 over what? X. Can I cross out any of the x's? No, because they are attached to that plus or minus sign. Good. All right, let's do 9. Factor, 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 factor. Factor top left. What can I take out of x squared and 2x? Negative 2x. I can take out an x, right? So I'm left with x minus 2. You guys agree? X plus 5 is good. 3x is fine. Can I factor this? What times what will give me a positive 5 when I multiply, but a positive 6 when I add? What is it? 2 and 3? Or 5 and 1? I need a 5 when I multiply, but a 6 when I add. So it's what? Plus 5 plus 1? Okay. So are there anything in the top and the bottom that's exactly the same that I can cross out? X plus 5 and x plus 5. Anything else? I have an x here, and I have 1 here. So what am I left with? I'm left with x minus 2 times x plus 1 over what number? Over 3. Perfect. Let's look at 10. It's just 4 factoring problems. That's all it is. Factor, 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 factor. Top left. What times what is going to give me a negative 6 when I multiply, but a negative 1 when I add? X minus 3 and x plus 2. All right, bottom left. What times what is going to give me a 16 when I multiply, but an 8 when I add? Plus 4 plus 4. What times what here is going to give me a negative 3 when I multiply, but a negative 2 when I add? Minus 3 and plus 1. And then what can I take out of 3x squared and 12x? 3x is x plus 4. You guys agree? Now, exactly same top and bottom. I have an x minus 3 here and an x minus 3 here. What else? I have an x plus 4 here, and I have 1 down here. I know there's 2, but you can only go 1 to 1. So what am I left with on top? 3x and an x plus 2. And what am I left with on the bottom? X plus 4 and x plus 1. Yeah. Now again, guys, remember, I'm doing this on a video, so you're welcome to rewatch this tonight. See it? All right, let's look at 11. Remember, this is over a 1, so let's factor. Top left, what times what will give me a negative 28 when I multiply, but a positive 3 when I add? Be x plus 7 and x minus 4. What's x squared minus 5 factor into? X plus 5, x minus 5. What about here? What times what is going to give me a positive 15 when I multiply, but a negative 8 when I add? X minus 3, x minus 5. So what is exactly the same on top and bottom that we can cross off? The x minus 5. So this one doesn't simplify a whole ton. This is left with x plus 7, x plus 4, and x minus 3, all over x plus 5. Some of them aren't going to factor a whole bunch. Some of them, everything will cross off, and you're left with a 1. Yes?
Isn't it x minus 4?
Oh, I put plus. Yeah, you're right. Thanks. Right here. Minus. Thank you. All right. These next ones are exactly the same. Exactly the same. There's one thing that is a tad different. What is that? You have to keep what? Change, flip. So I'm going to keep 2x cubed plus 10x squared over x squared plus x minus 20. I change my division to multiplication and I flip. This becomes x minus 4 over 2x squared. And then we do the exact same thing. You factor, 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 factor. Top left, what can I take out here? I can take out a 2x squared, correct? And I'm left with what? X plus 5. Here I just have an x minus 4, just leave it. 2x squared, and then what can I do here? What are the factors of negative 20 that multiply to give me negative 20, but add to give me a 1? Plus 5 minus 4. So, top and bottom, anything exactly the same. Minus 4 and a minus 4. Plus 5, x plus 5, x plus 5. 2x squared and 2x squared. If everything cancels out, guys, what's your answer? There you go. That's it. Don't freak out. Don't be like, there's no way. That's okay. That absolutely can happen. 100%. Don't freak out. Let's do 14. We're almost done. Keep x squared minus 10x plus 21 over x plus 2. Change your division to multiplication, and then you flip. So this becomes 1 over x squared minus 14x plus 49. And now we factor. Top left, what times what? Gives me a positive 21 when I multiply, but a negative 10 when I add. Minus 7 minus 3. X plus 2 is just hanging out. What times what? Gives me a positive 49 when I multiply, but a negative 7 when I add. It's going to be minus 7 and minus 7. And then again, anything exactly the same on top and bottom. X minus 7 and the x minus 7. So in my numerator, I'm left with x minus 3 over x plus 2, x minus 7. Anybody have any questions? 2 more, and then I'll give you your quizzes back. Let's look at 15. I can't even see it. So x squared minus 2x minus 3. Make sure I read it right, guys. X squared plus 2x minus 8. I'm going to go ahead and keep change flip. So times, and then when I flip it, I have x squared plus 6x plus 8 on top, yeah? And then on the bottom, x squared plus 4x plus 3. You guys agree? So, factor, 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 factor. Top left, what times what is going to give me a negative 3 when I multiply, but a negative 2 when I add? Minus 3 and plus 1. You guys agree? Right. Bottom left, what times what is going to give me a negative 8 when I multiply, but a positive 2 when I add? So it's going to be x plus 4, x minus 2. Agreed? Top right, what times what's going to give me a positive 8 when I add, multiply, and a positive 6 when I add? It's going to be plus 4 and plus 2. And then what times what is going to give me a positive 3 when I multiply and a positive 4 when I add? It's going to be plus 3 plus 1. This is one you got to be real careful because look, guys, all the factors are the same. What's the difference? The signs, right? So anything exactly the same top and bottom. X minus 3? No. X plus 1? Yeah. X plus 4? X plus 4? X minus 2, x plus 2 cannot cancel. So you're left with, in the numerator, x minus 3 times x plus 2 over x minus 2 times x plus 3. Don't get fooled and think you made a sign error and you should go back and everything cancels out. Trust yourself. You guys are all good at factoring. You can handle this and then you'll be perfectly fine, I promise. Let's do the last one. All right, 16s. X squared plus x minus 6 over x squared plus 7x plus 12. I'm going to go ahead and keep change flip. So times, and then when I flip, x squared plus x minus 12 over x squared minus 5x plus 6, yeah? All right, top left. What times what is going to give me a negative 6 when I multiply, but a positive 1 when I add? Plus 3 minus 2. You guys agree? Okay. Bottom left. What times what is going to give me a 12 when I multiply, but a 7 when I add? Plus 3 plus 4. Bottom right. What times what is going to give me a positive 6 when I multiply, but a negative 5 when I add? What would it be? Minus 3 minus 2. Good. And then up here, what times what is going to give me a negative 12 when I multiply, but a positive 1? X plus 4 and x minus 3. You guys agree? All right, what's going to cancel? X plus 3 in the top and x plus 3 where? On the bottom. I got a minus 2 and a minus 2. I got a plus 4 and a plus 4. And a minus 3 and a minus 3. Everything canceled. So what happens? Your answer is 1. Perfect. All right, I promise I'll go back and do that word problem on the video here at the end. I'll do it. I have planning next, so I'll do it. Okay, guys, on your test tomorrow, you will have a word problem, so don't be upset or don't freak out or anything like that. Just read what they give you, the information, and kind of decipher. Remember, time is always going to be talking about the x-axis, so your x variable. But in this question, it says the current Y in a certain circuit varies inversely with resistance. So they're telling you a lot of information right here. First of all, they're telling you that Y is the current. And they're telling you that X is the resistance. Another thing they also tell you is that it varies inversely, which means you use the equation y equals a over x. So they gave you two variables, y and x. They tell you what the current represents, they tell you what the resistance represents, and they also gave you values for that. They tell you that the current is 8 amperes, and they tell you that the resistance is 20 ohms. We're trying to figure out what the resistance would be when we increase to 25 ohms. So we're going to solve for A first. So remember, current is your Y. So I'm going to plug in 8 for Y equals A over, my resistance is 20, that's my X value. And then we're going to solve. So I'm going to multiply both sides by 20. So A equals 160. So you have the equation Y equals 160 over X. Now we're going to solve when the resistance increases to 25 ohms. So I have Y equals 160. I'm going to substitute in 25 ohms. It should be 160. I don't know why I wrote 165. This is 160. So then we're going to solve. So you can use your calculator. Y equals, and you get 6.4 amperes. And there would be your answer.